In this lecture, we are going to learn about gases. Please start homework as soon as you finish the lecture. So the chapter 9 is going to cover gases, and here is the summary of what we are going to talk about in terms of gases. And you can use these as study guide when you are preparing yourself for the exam. Okay, so these are the learning outcome for this chapter. So let's take a look at the property of gas, which is pressure. So this is going to be in chapter section 9.1. Please read the OER textbook for more detail. So before we get into the pressure of gas, let's review the characteristic of gas first from Chem 121. So pretty much if you focus on gas right here, you will see that gas expand to fill container uniformly and completely. And also gas can exert pressure on the wall of container as well. And gas diffuses and mixes rapidly, and gas is highly compressible. So these characteristic of gas right here is very crucial. Okay, so you need to understand this, that it will allow you to understand the rest of chapter 9. Okay, so let's take a look at the property of gas, which is pressure. So by the definition, pressure, if we talk about pressure, it's pretty much is the force exerted per unit area by gas particle. Okay, so in this case, if you have the gas molecule that collide with the wall of container, that collision of gas molecule is going to cause the pressure or cause the force that is exerted to the area of the container. Okay. So if you're looking at the number of molecules of gases, so let's say that we have the same volume of the container A and B, but container A, we are going to put less molecule of gas into, which are 10 molecules, and B would be 20. So in this case, if you compare how many collisions that is going to happen between A and B, it's clearly that A, because there are more molecules, therefore it's going to cause more collisions between gas molecules and the container walls. Okay, so in this case, because container A would have more collision of the gas particles against the wall of container, therefore it's going to have greater collision, therefore it's going to be higher pressure as well. In this case, we can conclude that container B would have higher pressure than container A. So therefore, in this case, if you talk about pressure of gas, know that the more number of molecules causing more collision, the pressure of gas would be higher. Okay, so this is the fundamental concept that you need to understand. Okay, so now the next thing before we get into learning more about gases, we need to actually define some of the terms that we will use the most. Okay, so one is the atmospheric pressure, and also the device that is used to measure the pressure. Okay, so which is called barometer. So let's take a look at atmospheric pressure first. So pretty much atmospheric pressure is the pressure that is going to come from the gas, the atmospheric gas, right, that exert their force against the surface. Okay, so in this case, if you're looking at this, it's just pretty much the amount of gas at present on Earth, right, and the gravitational force is causing those gas exert that force on the surface. Okay, so that is defined as atmospheric pressure. Okay. The device that used to measure this is called barometer, and barometer is made of mercury. So what it is that this tube right here is going to be a vacuum tube, and pretty much if you are going to put this tube into a chamber of mercury, and as you see, the atmospheric pressure or the atmospheric gases will put pressure against this mercury and push it up inside the vacuum tube, and causing mercury to rise to a certain height. Okay, at sea level, this height of mercury is come out to be 760 millimeter. Okay, so we define that at sea level, the atmospheric pressure would be 760 millimeter of mercury. So that is what how we measure the atmospheric pressure. So Thor is a scientist who invented this barometer. So sometimes this unit right here, millimeter mercury, 760 millimeter mercury. Sometimes we also call as Tor as well. So just named after the scientist who invent barometer. So these 2 mm mercury and Tor are the same. Okay. Why don't we use water? Why we use mercury? Well, it's just because if you use water, the height of the water column that is required is going to be 34 feet high, which is not very convenient. So therefore, in this case, that's why we are using mercury. It's just because of that, because it's more convenient. It's within what do you call, like appropriate height, instead of like have to carry 34 feet high of water column, right? So it's just not very convenient. Okay, so if you're looking at 2 different places at sea level, so as I mentioned before, at sea level, atmospheric pressure is going to be at 760 millimeter mercury. However, if you go, let's say, at a higher altitude, that is not going to be the case anymore. At a higher altitude, it's going to have less amount of air or amount of gases available. Therefore, in that case, it's going to be less pressure. Therefore, you are going to see the decreasing of the atmospheric pressure at a higher elevation. Okay. On the other hand, if you go to the valley, which is lower than the sea level, then the atmospheric pressure would be greater than 760 millimeter mercury. Okay, so let's summarize this. Okay, so if it's sea level would be 760 millimeter mercury, right? If it's lower than, sorry, if you are going at higher elevation, okay, so this is sea level. Okay, so higher elevation, then the value of atmospheric pressure would be less than 760 millimeter mercury. If you are go lower than sea level, then it's going to be greater than 760 millimeter mercury for the atmospheric pressure. Okay, it just depends on the amount of gas are available. Okay, so here are the units that used to describe pressure. Something you probably be familiar the most is the PSI unit, right? Because when you are going to pump air in your car tire, you are going to go off by the PSI unit. But in this course, what unit we are going to use the most would be Tor millimeter mercury, okay, or atmosphere, okay, which is ATM. Okay, so those are the units we're gonna use the most, and the unit conversion for this would be right here. Okay, so this unit conversion would be provided for you on the exam. Okay, so on the first exam, chapter 9 is going to be provided for you. But later on, my expectation is for you to actually memorize this and understand that what are the conversion for between atmosphere, millimeter mercury, and Tor. Okay, so let's take a look at unit conversion. So since we talk about different units here, so my expectation also, you should be able to go between ATM, millimeter mercury, and Tor. Okay, so let's take a look at one. Okay, so 35 ATM to millimeter mercury. So pretty much in this case, recall from Chem 121. Okay, so you're gonna set up 35 ATM. Okay, so ATM would be on the bottom, and then on top would be millimeter mercury, because that's what we want, right? And then you are going to get answer in millimeter mercury. Okay, so on the exam, I expect you to set up the equation that show me the unit cancellation like this. Okay, so this unit cancellation right here. Okay, number 2, same thing. We have in this case we have inches that we inches mercury that we need to convert to Tor. So in this case, we know that going from inches to Tor, you don't have direct conversion, but from Chem 121, we know that inches, we can convert that to centimeter, right? So 1 inch equal to 2.54 centimeter. Next would be convert from centimeter to meter, right? There are 100 centimeter equal to 1 meter. So the last one, because we have meter now, we can convert to millimeter. So we know that there are 1,000 millimeter are in 1 meter. Okay, so far if you do this, you should be able to cancel inch, okay, centimeter, meter, and then you are left with millimeter. But we are not going to stop here because we want torr. So the last unit would be, we have 1-to-1 ratio between millimeter mercury and torr. So in this case, you can just use 1-to-1, or you can use 760 and 760. That's fine as well. It's still 1-to-1 ratio. Okay. So if you set this up, again, if you're looking at this, the given number contains 3 sig fig. Okay, same thing for this, right? This is 2 sig fig right here. So therefore, the final answer should contain 3 sig fig. Okay, so this is 3 sig fig with the proper unit. This is 2 sig fig. Okay, so again, this is going to be the review from Chem 121 of the unit conversion. Okay, so that's why Chem 121 is very fundamental for this class, because you need to obtain those skills in order to do well for this class. Okay, so if you have not mastered in this unit cancellation yet, this is the time that you need to get it. You have to get it down. Okay. All right, so let's take a look at next. Okay, so the next thing we're gonna take a look at. All right, so here is a summary of chapter 9.1. Okay, so we pretty much talk about gas pressure, and we talk about the unit that we are going to use throughout the whole chapter 9, and you will need to be able to convert between each of those units. Okay, so here is the homework, chapter 9.1. Newton homework might give you a different unit as well for you to work on. For example, Pascal or PSI. All you need to do is use their conversion factor to convert from unit of the pressure from one unit to another. Okay, but the idea is still the same. It's coming from chapter 1.5 from Chem 121 that allow you to do the dimensional analysis. Okay, if you have any question, again, please do not hesitate to reach out to me.